Hi, good afternoon, everyone. Hopefully everyone is able to hear me. I just wanted to check in to see if you can hear me now. You can reply on the chat window out there on the left or right, actually, to see if everyone's hearing me okay. Okay, perfect, good. You should be seeing a splash screen with the presentation for this webinar. We're going to, this is our fourth webinar in this series. We're going to focus today on a little bit on equipment and how to sort of plan out your actual facility needs for your makerspace in particular. Again, myself, Solomon Nagla, will be on the webinar PowerPoint here. Deborah, who's also joining us as a panelist, will be answering questions through the chat window, or you can use a Q&A right on your bar there, so that you can record any questions. We can follow up with a lot of you either during this webinar or afterwards. Okay, we're going to dive right into it, since a lot of this is. Let me give me 1 second here. Let me remove some windows from my. Okay, here we go. It's going to be very general regarding the equipment list, since a lot of us that are new to this space may not know the particulars about the models and makes and bells and whistles. This is more of a workflow to try to engage the development of the selection process of equipment. So you'll see that more about the design of the makerspace itself and the considerations for this. On anything related to the budget, specifically to many of the topics we've been talking about, we'll cover on Friday. There's a specific method that many of you have noticed, that the worksheet that was sent out last week needs to be inserted with detailed information. I do want to say that for equipment, you don't have to have the make and model all detailed out in the budget, but you should know approximately what equipment you're using and the ranges that you're considering, so that you can put enough funds in your proposal. And again, more about that on Friday. So I'm going to stay away from the budgetary considerations of equipment for today. Okay, so a couple of things. We want to make sure that we review the key outcomes for the CCC Maker initiative. How do we incorporate instruction and technology and the various modules of a makerspace and the equipment? Just a recap of due dates. I want to put this almost every single time we meet with each other, so that you can see that there's specific outlines there. I'm going to skip this one for now, but I think a lot of you have seen this throughout the webinar series. Again, some of you have already shared with us a Dropbox account that many of you have set up in a folder for your specific college. Please feel free to submit that to Deborah and myself, so that we can begin working and interacting with some of the files, specifically as you submit the files for the deadlines. Okay, so makerspace itself is one of the 4 key outcomes. Again, yesterday we talked about internships. Now we're going to move over to makerspace. And it's an intersection about the curriculum itself. As you can see, that's starting to look into that. Almost many of you represent various distinct disciplines across the making community. And so, I'm going to stay away from the curriculum itself, but you have to conceive your curriculum in some method for this particular exercise of choosing the right equipment and the right layout of your makerspace, and the location and modularity, all those sort of considerations. You do have to consider to some extent the discipline and the curriculum that it's meant to serve. But again, since that's going to be very broad, I'm not going to start with that. I'm going to start with a bit more tangible, which is the equipment itself. So a couple of things that I'm operating under. So these are considerations that I want to make sure everyone knows that we're approaching this topic, is that anything that may reduce techno stress is the best remedy for much of this. So the idea is that embracing the makerspace philosophy is that you're going to learn just enough to be dangerous, but of course in a safety way. But the idea is that you kind of work backwards from a project that you're trying to achieve and develop the technology to support that. So, and again, just diving in and making a project at your local makerspace, if there's one commercial one that you have access to, or a vendor that allows you to work and tinker with equipment. It's a way to just quickly get up to speed with much of this much of the technology. One of the aspects that really was successful is that you're going to have to hire some assistants for the equipment, whether for classes or out of class, or just general oversight of the equipment and technology for maintenance and some skills transfer. The idea is that you don't spend too much time sort of delegating to class time in terms of button pushing. That's covered, outside of class, or as students are assisting you in the space that you're teaching. Sorry, TAs helping you in the space that you're teaching. So that's something that you want to consider. How is it that you're going to get assistance for the technology? You want to collaborate with local vendors. They have a wealth of knowledge and know-how, so you want to make sure you have access to them through either physically or through YouTube videos or even meetups that allows you to obtain some of this information of how to use the technology itself. Lastly, something that is of high consideration is to build a community for further skill transfer. In other words, how do you work with your student clubs, possibly volunteers, either local engineers or local individuals that may be part of the meetup group that can actually help that community, so that everyone understands proper use of technology and proper use of the equipment. Okay, so with that said, some of the considerations for the curriculum itself. So let me give you an extreme example. Never did we ever consider developing classes that are technology specific. For example, a laser cutting class, right, or a 3D printing class. In other words, the curriculum should incorporate a little bit of the technology, even at the fundamental level, and essentially you just go in and touch as much technology as you could in the CAD digital world, and the digital fabrication world, even the machine shop or wood shop or welding or anything that you can cobble up in your makerspace, and go in a little bit for the initial project, and then just go much deeper as the course or the program evolves. And so the idea is that you're covering process over a specific skill in any one technology. One thing that really helps is to test projects with advanced students, and then kind of do a multiplication factor so that you can imagine what a novice or how a whole class time frame would look like. And this is just for planning purposes. You don't want to have 30 people waiting for one piece of equipment, and most of the class time or student time is spent waiting for that. So that's a good methodology just to consider your layout, is this aspect of, do you vary enough technology in there for your curriculum, and do you have enough of that so that you have a lot of wait time happening. And so because of that, you want to consider what is called project throughput. In other words, how much time a student spends for that project. Going back to the initial consideration that you go in, very minor on the technology first, you should be able to do initial projects quite quickly so that you transfer basic knowledge of every piece of technology as quickly as possible, so that shouldn't take a lot of time. And then, wait for either further along the class or further along the program where students are spending much more time on technology or on a specific project. And the one thing that you want to make sure that you consider amongst your colleges is just make a list of required technology, so that the questions you want to ask vendors. If it has certain bells and whistles, does it contain certain parameters that your faculty or students are looking for? Try to make a list a bit ahead of time before approaching, and that way you can assess accordingly to your needs versus considering looking at everything at once. Again, just a little bit of curriculum aspect in consideration to your technology. These equipment modules that I have up here on this particular slide are just considerations for most makerspaces. Again, it's not meant to be all-inclusive, but this is, I took this from one of the links that I'll share with you in just a moment. You want to have general workspace area, again, mostly tables, big flat tables with benches, movable chairs, that type of area. General tools, from, screwdrivers, different fasteners, hot glue guns, all those sort of, general tools to just do a variety of projects. Some quick, maybe non-discipline specific, of course. Then you have more woodworking and metalworking. Some of you actually are within those disciplines, so that makes perfect sense. And even if you're not, these are considerations that you may want for your projects because you're always going to be using some level of wood or metal for much of your projects. And so you want to consider some aspect to that, from model making all the way to more industrial woodworking or metalworking equipment. Electronics is something that you want to make sure you have the room for. It takes special care of the actual bins where small little things exist, and you want to make sure that the benches have proper ventilation, those sort of things. So electronics is a big part of it as well. Textiles is something that allows for softer materials like cloth, vinyl, leather, including even wearable electronics. And so you want to make sure you have from either handheld or industrial sewing machines to possibly other tools that you may need for threading things up. Obviously, computers is a consideration. Many of us work in computer labs in our colleges, and although a computer lab is useful for putting students together in a big room, having computers thought out through a makerspace may be helpful, so that students don't have to walk back to a computer lab and then walk back to your makerspace. So having some sort of level of computer system and full support of that would be advisable within the vicinity of your makerspace, and maybe not a whole computer lab necessarily. Lastly, the traditional digital fabrication technology of 3D printing, laser cutting, and any CNC. Machinery is typically the staple of most makerspaces because of the connection to our digital files, whether it be 2D CAD or 3D CAD. And so those are technology that are, again, they're multiple sizes, multiple envelopes, and for multiple materials. And I think that's just something you have to consider based on your discipline and your curriculum. Okay, you do want to consider safety in your planning aspect of your makerspace, obviously. Again, this is not meant to be all-inclusive. There are many aspects to safety that needs to be considered depending on your equipment. But you want to make sure that you consider space around the machines, not just literally butting it up against student chairs or student desks. You want to consider even safety guards so that if there's anyone walking, no one trips, accidentally runs into any of these machines, or if students are putting their hand in to hold a piece of material that they're machining or something. You want to make sure that there's proper safety protocol on a lot of these machines that you'll be considering. Many of these machines, especially on the CNC end, do generate a lot of sound and debris. So you want to consider, how are you collecting the debris? How are you moving the debris across the machine or in the room? And is it going to generate a lot of sound? And if you have a machine that's generating sound next to your workspace, you want to consider the fact that people may be working nearby. Some of the less obvious are kill switches or keys to turn on machinery. These seems to be quite helpful in terms of not only safety, but also makerspace management, where if you have a key that needs to be checked out to turn on the machine so that no one just walks into the makerspace and turns things on their own, this would be a good way to regulate who has access to it by checking out a key and then checking the key back in. And of course, kill switches are just when the machine is operating. Does every machine turned off at a given moment if something were to go wrong, lifting up a lid, a bit red buttons, things like that, and most do. Lastly, you want to consider electrical, air, water connections and plan them through with your facilities. This has been a very important part for many of the equipment that uses higher voltage, that uses compressed air or ventilated air, or even some water for chilling or cooling, or even water jet cutting, for example. So those are considerations that you want to plan and price through with your facility folks. Lastly, access to equipment you can either access the equipment through an assignment, through a class, or badges. In other words, how are students going to interact with the technology? It's just a good way to sort of manage the safety of the space. If a lot of folks are just giving open-ended projects and all the students are expecting to use certain equipment that may pose a safety concern, or of course even just a throughput concern. But just think about it, how you can ramp up through assignment or class, or even having folks plan out badging systems so that you have some level of control of the flow in the makerspace, and who has access, who doesn't, and who should be there, who shouldn't. So things of that nature are important for safety considerations, as well as just the bandwidth that is going to be of necessity for your makerspace personnel and materials and machinery. Just some very simple equipment considerations. Please contact local vendors for demos. And again, think ahead about your requirements. Many of you that will be joining us at the Maker Fair next month will have access to seeing a lot of vendors that, at least the equipment of those, of which you can then follow up with vendors. And so that would be a good way to explore if you haven't seen a lot of this. More than likely, if you're interested in some sort of machine, there's an educational partner that will be attached to you. These typically separate commercial and educational sales force, so that's something that you also want to consider. For those of you that are starting new, a laser cutter, although it sounds high tech, it's really more than it's just a little bit more than a sophisticated printer. So it really just works much like a printer. You hit the print button with the right settings, margins, font, those sort of things, and it actually controls a lot of the printer itself. So you just really want to consider the 2D area that you're working with and the laser wattage, which will control how powerful it may be. And again, those are some really large laser cutters to something that's pretty small. Same thing with 3D printers. The envelope is of consideration, something that's going to be small for jewelry, even though you know, it's maybe more sophisticated because of the material itself. It's something much larger that may take less expensive material, but will give you the volume and the envelope necessary. Again, that's specific to your discipline and your curricular needs. Lastly, CAD, computer design software, is typically aligned with the industry that you're working with, almost exclusively, just because folks going into more architectural, construction technology use specific software for that. Same thing for industrial designers. They may use specific software, and then separate for mechanical designers, as well as even electrical designers. They have specific software needs that are typically interoperable. So for folks that may know a lot about that, would definitely be of some resource, but you know, don't be afraid to ask the vendors and to see if that's the best solution for yourself. So I'm going to share with you a couple of websites that are of much help in terms of digging in deeper with regards to makerspace technology and makerspace layout. You are going to see them in the PowerPoint I'm sharing with everyone at this moment, but what I'm going to do is I'm going to jump over to the comment box here in a moment, and you may see the presentation flicker a little bit, but oops, give me a sec. I'm going to go over the chat box, and I'm going to send over these links to everyone so that you have them through the chat box, and you can click on them, I believe, through the chat box, and even copy them over to your desktop or to some other document, but everyone should see now on their chat window all these links live that you can actually click on as I'm speaking here and check them out. I mean, they're a variety, from the very mundane supplies and equipment to much more sophisticated brand and considerations. You may want to take a look at just general price ranges for your budgeting needs. So in other words, are you going for a large piece of equipment that you need a budget, $50,000 for, or are you deciding to go with 5 smaller pieces of equipment that does the same thing but are going to tally up to the same $50,000? Those are the considerations that you maybe want to have, is make sort of broad estimates of the cost value of each equipment that you're considering for your makerspace. I do want to plug in, there is a Slack channel group that we have there at the very bottom, cccmaker.slack.com. I don't think that's included in the links that I put in the chat window, but you may want to go there to sign up. And there is a thread called Tools and Tech. So folks that have jumped onto the Slack channel are sharing little key notes about the different tools and technology they're considering. Many of us have worked with several vendors or pieces of technology, and you can get our input there, or post a question or post something that you find, and then we can all sort of chime in and benefit from that for those folks that are interested in continuing the conversation after this webinar. Okay, that's about it for considerations on the technology and makerspace layout that we have for you. Again, it's meant to be a brief webinar to give you some direction. And as I provided some links there that will definitely take you much deeper. I'm going to look over to the Q&A or the chat box to see if there's anything that I can address here. Definitely want to make sure that folks use a Slack channel to answer any more pertinent questions with technology, which does seem to be a sort of point of interest. I'm going to read some questions if I feel they haven't been answered over on the chat. Feel free to pose a question as well. One question that comes up, and I think it's helpful, many of us reside in either the northern part of California or southern part of California. There's many commercial maker spaces that folks may have access to. I recommend to attend one. When Deborah and I have been sort of going around to various maker spaces across California, and these are commercial maker spaces, they have a lot of this in mind. They have the layout adequately considered. They have the checkout, the control of the access to technology considered. So they've thought a lot of this through for the general public, which is something that you can use. One aspect that is maybe of consideration in an institution like ours is having students swiped in. Many of you have that in your tutoring centers. That's something that you want to make certain that you can maybe record the traffic that's being used, or even the students that come in and out, or not only usage, but maybe just history. If there's something that were to occur and there was a record of someone being there or not being there, that may be of some help for us in our institutions. There was a question about vendors being at the education day. There's not going to be any vendors necessarily at the Friday event. I'm certain that there'll be many vendors at the General Maker Fair, which everyone's invited to for Saturday and Sunday, and would recommend to talk to them. And this is a way that you could spend a lot of time learning about the technologies and up and coming tools. One thing I forgot to mention in there is virtual reality. A lot of the new technologies that I see coming out there, integration is with VR, and that's something I did not link specifically up here or mention that, but that's something that some makerspaces may already have, and you should consider. Again, anything related to cost, it really depends on many factors. Your curriculum, your industry, the space it can fit in. So there's too many variables probably to be considered to say, yep, this is what this should cost, or this is how much. You can get one large thing or a bunch of small things. So I mean, it really is something that you need to discuss with your institution and what you're planning to develop.
Can I just jump in there for a second, Salomon?
Oh, please do.
Yeah. Hi, everyone. Yeah, don't think you've got to go out and buy everything all at once. One of the things that we did was we had a couple of 3D printers to start, and then as the demand for it increased, because 3D printing, it's time consuming, so we needed bandwidth. So rather than going out and buying one more large 3D printer, we actually bought 3 smaller ones, and we've added several to that. And the beauty of that is that we were able to buy a couple of different brands of 3D printers that were smaller. So students got to use a variety of different 3D printers. And it also meant that we weren't having to invest $20,000 every time. We could buy one for a couple of $1,000s. So it's not necessarily about having the biggest and best and newest. It's often about having the bandwidth to accommodate the volume of printing that you need. Thanks, Salomon.
Yeah, absolutely. Yeah, I mean, everyone, I think, as Deborah mentioned, may consider that just simply because of the fact that some of us do not have a space to begin with. And so starting small in literally a movable cart that you can reposition in your classrooms may be the way to start. I mean, I know that about 10 years ago, that's literally how a little CNC mill and a little 3D printer that I could push around is essentially was my show and tell to get folks on board before any more space was dedicated to larger equipment. So, again, it's every institution will be different, and that's something that you just want to plan out throughout the years to maybe acquire even more expensive or larger equipment later on. Again, please jump onto the Slack channel if there's a specific equipment you want to share, models, and different details. I would recommend those to be a good way to just continue the conversation.
Yeah. I'm seeing a couple of questions too about the floor plans, equipment lists, etc., for the makerspace that you're proposing. Please bear in mind that with the implementation plan that you're currently working on, this is not intended to be absolutely detailed. We're trying to get people to think about this as an integrated system. And so after you've put in your implementation plan with, you don't have to have a fully developed space plan for your makerspace. I mean, a simple sketch would probably be sufficient for these needs. And as we move forward towards the June deadline, we can help people build that out a little bit more. So think about this in general terms. You don't need to get down to the level of individual brands, etc. It's really about how you're going to use the equipment to support programs and students.
Good. It's okay. It's 12:30. I see there's maybe a couple of questions that are coming through. please reference the implementation plan for some of the details of the narrative. Remember, a lot of this effort that we're doing through this webinars is to make sure you have a workflow that you're implementing and that's working through the narrative into your internship planning or even your makerspace planning as well. There's a question about May 19th. That's the Maker Fair. Actually, that's the celebration day over in the College of San Mateo. There's going to be, actually there was already a email sent out regarding your template for PowerPoint presentation. I think it's a 3-minute presentation of your makerspace planning.
And we'll have a more detailed agenda coming out. Monday we have a webinar scheduled for the event too. So we're just putting the final touches on that.
Yeah.
Um,
okay.
Yeah.
Anything else?
Well, I noticed that Paul Clark asked what the most expensive piece of equipment is. I mean, well, there's a lot of specialized pieces that, you know, that might be specific to a program, but generally I would say the most expensive thing you're going to buy at this point would be a laser cutter, and that's because it's the laser cutter plus whatever it's going to cost for the ventilation system. So I hope that answers your question. And Hillary, yes, we will look into VR vendors. That's a new area, and I know that Hacker Lab in Rockland has a VR setup and has a very knowledgeable person there. So we'll draw them in to look after that aspect, I think.
Okay, everyone. So hopefully this helps you at least begin the concept of searching for information out there. And I mean, there's a wealth of information online on those links and in any variety as well. If some of you are asking about mobile makerspaces, there's several links that I ran across for mobile makerspaces. There's even a method to do so with a trailer and consideration of hauling equipment and things like that. So that's something else you may want to consider for many of you. And there's many examples of mobile makerspaces at your local commercial makerspace, because that's a lot of them operate that way, and they take their makerspaces to like birthday parties and things of that nature nowadays. So, okay, everyone, thank you very much, and you have a great rest of your day, and enjoy the rest of your Wednesday.
Great,
Bye-bye.
and we'll see you on Friday. Thanks.